Hey folks, welcome to DSA in Python course. Today we are going to learn about a very new section here. Today we are going to learn about recursion. So what is a recursion? Basically, it is a way of solving a problem by having a function calling itself. It's a method of solving a problem where the solution depends on the similar sub-problem of the same problem. So basically, the solution depends on the sub-problem of the same problem, original problem. So it is a beautiful example of a recursion, real life example. So I have given this box to my girlfriend. She opens a box. It contains a box. She opens it once again. Then she is frustrated now, and I tell her to open it one more time. So we get our final result. Basically in 5 times. Basically we are calling the our function 5 times. So what are the features of recursion? So basically, first is performing the same operation multiple times with different inputs. So basically we have given here 5, 4, 3, 2 and 1. We try to divide the given input to make the problem smaller until the problem is solved. We open the boxes until we get the solution or the reward or ring. So one thing is necessary. The base condition is needed to stop recursion, otherwise infinite loop will occur. So it is real life example, but in programming it may happen if we not give the base condition to recursion, it may go to infinite loop. So we will see examples of it to understand more. Moving on to the next section, example of recursion. Here you will understand exactly how recursion works. So basically I have defined a function named open gift box. This is the example of the this is a program for the example for the previous slide. So I defined a function named as open gift box and given a base condition. Remember base condition, if the box is equals to 1, then print girlfriend is happy, else print uh, then recursion function is called. Okay, I have given 5. So basically how the output is, how we find this output, we will see in the later section of the video. Moving on to the next part, advantages of recursion. What are the advantages of recursion? Here you can see you only need to define the base case and the recursive case. So the code is simpler and shorter than the iterative code. I have already mentioned that every recursive problem can be solved by iteration also, but we do it by recursion to make it simpler and shorter, easy. The next feature is some problems are inherently recursive, such as graph and tree traverser problems. In this, only recursion can be used to solve the problems. When we will see the graph and tree section, you will understand more. Moving on to the next, it is very important for interviews because it is used in many dynamic programming and divide and conquer algorithms. Moving on to the next part. So when to use and avoid recursion. So I have mentioned that every recursive problem can be solved by iteration also. Then why we are using recursion, and when to use recursion and when to avoid recursion. So basically, when the problem can be broken down into similar sub-problem or sub-problems. Okay, moving on to the second point, where saving time and space is not our priority. Moving on to the next point, where while traversing a tree. We will see in trees and graph section also in very detail. Fourth section, memoization. Reducing, it also reduces time complexity. Memoization is basically a technique in which we remember the previous results and use it in the future. Okay, and when not to use recursion, if the time complexity and space complexity is important. If it is if we have a problem in and we have to solve it in strict deadlines, like in competitive programming problems, so we will not use recursion. If it is not a tree or graph problem also, we will not apply recursion. Recursion is slow because it uses stacks. So maybe we'll see the concept of how a stack is implemented in recursion. So how to write a recursive function? Here we have taken example of factorial problem. So first step is the writing the formula. So the formula is n factorial is equals to n into n minus 1 factorial. So basically this is the formula for factorial. You know how we find the factorial of a number in mathematics? Like we have to find the factorial of 5. So we multiply it by 4, 3, 2 and 1, and 5 4 is a 20, 23 is a 60 and 62 is a 120. This is how we get our factorial result in mathematics. But in uh, computer science, we use recursion and iteration to solve the problem. So we are using solving it by recursion. So first step is writing the formula, that is this thing. Moving on to the next part, we have to mention the base condition. You know, the if condition we have applied in this is called base condition. Base condition. So there are two base conditions for the factorial. You know, all 0 factorial is 1 and 1 factorial is also 1. So these are the two base conditions. Third, we have to also consider the hidden cases. You know what is the factorial of minus 5? It does not exist, right? So basically we have to find those cases also. You may be thinking, what is this all bullshit? So basically this is nothing. It is a stack implementation of factorial program using recursion. So we are seeing this stack and we have to find the factorial of 5. So basically we are putting this 5 into stack. You know, in stack uh, the first in last out principle is followed. So basically what happens is the data element which we put into the stack first will be taken out or popped out at the last. So we push 5, then we push 4, then we push 3, then we push 2 and then 1. So our stack is filled. So where it's time for popping out the elements. So first we pop out the 1, then we multiply it with 2, then 3, then 4, then 5. So 2 1s are 2, 2 3s are 6, 6 4s are 24 and 24 5s are 120. So you may be thinking, okay, how it happens in program. So we will see it now. It is a beautiful program of factorial using recursion. So do you remember the base condition that factorial of 0 and 1 is 1. So basically the factorial of both 0 and 1 is 1. So this is the base condition and it is our first step. The second step, so this is the second step basically. First step is writing the formula, that is n into factorial n minus 1. So do you remember we talked about the formula? So we have to write the formula in the else condition, and in the if or elif condition we have to write the base condition, that is factorial of 0 and 1 is 1. And the third part is hidden case. The hidden case is all the negative numbers. So the factorial does not exist for negative numbers. So if we put the 5, we get the output 120. So here we discussed the basic recursion and how recursion works, and you learned the how to write the factorial program using recursion. In the next section, we will solve hell lot of problems on recursion to clear your concepts very clear. Thanks for joining the session.